Not all screws are alike. You can choose from different lengths and diameters, as well as from types of screw, depending on your application. Wood screws, drywall screws, and decking screws are all variations on a theme: a flat head, a tapered body with a wide pitch, and a pointed end. They vary in thread and composition to allow for different applications. Machine screws are twisted into a threaded opening and often hold together small automotive or mechanical parts. Sheet metal screws have a wide pitch that does not require a threaded hole, but instead uses the body of the sheet metal to form an internal thread. One type of sheet metal screw is hard enough to be self-tapping and creates its own internal threads in soft metal. In addition, screws are made of different materials, such as stainless steel, brass, aluminum, Teflon, and nylon. They can also have varying finishes, such as zinc or black oxide, or can be galvanized for exterior applications. Wrenches, nuts, and bolts. Nuts and bolts are threaded fasteners that fit together, interlock, when the bolt is inserted into the nut and rotated. Wrenches are the tools that provide the torque to fasten them together. Because bolts and nuts come in a variety of shapes and sizes, wrenches are also available in different sizes to accommodate that variance. You determine the size of a wrench by the size of the nut or bolt on which it fits. You can find both metric, usually measured in millimeters, and English system, measured in inches and fractions of an inch, wrenches. Manufacturers normally stamp wrench sizes on the side of the tool. A size of 10 mm means that the opening of the wrench measures 10 mm across the flat part of the jaw, and that it fits on a bolt head that is 10 mm in diameter. Figure 8.11 shows the most common types of wrenches, which are described in the following list. Open-end wrench, built so that its jaw, the crescent-shaped open end, fits exactly around a bolt or nut of the same size as the wrench. The opening normally sits at a 15 degrees angle opposed to the handle to facilitate working in tight spaces. The ends of most open-end wrenches are different sizes. 1. Slotted. 2. Phillips. Adjustable wrench, looks similar to an open-end wrench, but has a thumb wheel just below the opening that lets you adjust the jaw size to exactly fit nuts and bolts of different sizes. Adjustable wrenches are available in lengths from about 4 inches to about 20 inches. The longer the wrench is, the larger the opening will adjust. Box wrench, completely surrounds the top of a nut or bolt with its box, or notched circular opening. Although the design does not allow for work in very tight spaces, it allows you to apply more force with less slipping. Box wrenches are not adjustable, so you need a different one for each size nut you must turn. Combination wrenches have one box end and one open end that are usually the same size. Socket wrench, like box wrenches, fit over the bolt or nut, but with a different design. A socket is a metal cylinder that has a square drive hole on one end to attach to a common driver, ratchet handle, while the other end has a cutout that fits over the bolt or nut. The socket wrench provides quick work for tightening or loosening tasks, because the ratcheting action, the power stroke, is in only one direction, allows the socket to stay in contact with the nut through either process. Sockets are available in a variety of sizes, shapes, and depths to accommodate different tasks. Extensions fit between the handle and the socket to allow you to access hard-to-reach components. A torque wrench is a special type of socket wrench with a handle that measures the resistance to turning a bolt or nut. One type uses a beam and pointer to show the 1. Open-ended. 4. Socket. Torque on a scale, you turn the wrench until the dial indicates the desired torque. Another type has an adjustable drive head that you can set to click when it reaches a certain torque. Pipe wrench, also called a monkey wrench. This is an adjustable wrench with the jaws set at 90 degrees to the handle. A pipe wrench is most often used for bending or twisting pipes, as in wrought iron work and plumbing tasks. Allen wrench, used to turn screws with hexagonal, 6-sided, socket heads, also called a hex key wrench. This type of wrench usually comes in sets of varying sized wrenches, and is often L-shaped. You can also buy a set of straight hex key wrenches that are held together in a knife-style holder, where the knife part acts as the leverage for turning. Now let's talk about the fasteners that wrenches are used to turn. Threaded fasteners use the wedging action of a thread to clamp two parts together. The most common types of threaded fasteners are screws, bolts, studs, and nuts. Bolts screw into threads on a nut instead of a threaded hole. Some bolts look like hex head screws, but machine bolts have a square head, and are used where strong fasteners or close tolerances are not vital. You normally use two wrenches to tighten or loosen bolts, one to drive the bolt and one to hold the nut. However, the head on a carriage bolt has a square base that locks into the part to keep the bolt from turning as you tighten the nut. Studs have threads on both ends. One end of the stud fits into a threaded hole in one part, then another part fits over the other end of the stud, and the two parts are clamped together with a nut. You will normally see studs in areas where positioning is important. Although a stud can have threads down its entire length, it usually has threads only on the ends. Nuts are fasteners that have internal threads to accommodate the threads on bolts or studs. You can use a box end, open end, or socket wrench to drive a nut. Other types of nuts include wing, stop, and thumb nuts. You tighten wing and thumb nuts by hand, and use stop nuts for permanent fastening. Hex lock nuts are common in applications where parts undergo a lot of vibration. The cone-shaped end creates a positive lock against the bolt or stud. Castellated nut with a cotter pin keeps the nut from working loose after it has been tightened. After you tighten the castellated nut, you insert a cotter pin through slots in both the nut and the bolt, and bend the ends of the cotter pin around the nut. Hammer and nails. Another common means of fastening wood together is the nail. Nails are driven into the wood with blows from a hammer, and get their holding power from the wood fibers pressing up against their sides. Many jobs require a hammer, but because different hammers accomplish different tasks, they are not always interchangeable. Figure 8.12 shows common types of hammers, and following list provides descriptions for those hammers. Figure 8.13 illustrates the parts of a standard claw hammer. 1. Claw hammer, used for driving and pulling out, with the claw end, nails. This type of hammer is also referred to as a carpenter's hammer. A tack hammer looks like a small version of a claw hammer. Claw hammers are not good for automotive or other metal work, because the metal part can cause the hammer face to shear. For repair jobs that require a softer head, use a soft face hammer, the most common of which are made of brass, rubber, plastic, and rubber-covered steel. Wedge. Mallet, used for tapping objects such as chisels, dowel pins, plugs, and metal, where the aim is to avoid deforming the surface being struck. In addition to steel mallets, some have heads made of softer materials such as rawhide, wood, plastic, or rubber. Ball peen hammer, used in metal work for shaping metal, tapping parts into place, and riveting. Ball peen hammers are the ones most commonly used in automotive repair. They have rounded heads and are used to drive punches and chisels. Never use the ball peen hammer directly on automotive parts, because its hardened head can dent or damage the part. Rivet gun and rivets. Rivets are non-threaded fasteners that are used to permanently fasten metal, as in automotive or aircraft work. A rivet is a soft metal rod with a head that is used for tapping the rivet into holes drilled in both sections being joined. The end of the rivet is then flattened out by hammering to prevent it from slipping back out. Rivet guns, also called pop rivet tools, and shown in figure 8.14, are special tools that speed up the riveting process. To use a rivet gun, you feed a rivet into the nosepiece of the tool, and then squeeze the handles of the tool so that it grips the rivet. Next, you place the rivet gun over the pre-drilled hole and alternately open, and close the tool's handles to draw the rivet's mandrel, long, narrow stem, up into the tool. When it becomes difficult to work the handles, you have applied enough pressure for the rivet to hold. Squeeze the tool's handles harder one more time to break off the excess part of the mandrel, and your rivet is set. You can then form the small end of the rivet into a head with a rivet set, or a ball peen hammer. 1. Rivet gun. Other non-threaded fasteners. In addition to nails, other non-threaded fasteners aren't used to pull materials together. Instead, they hold parts in place, maintain distance or aspect, or keep parts from falling apart because of vibration. Figure 8.15 shows you these fasteners, and the list that follows describes each. Washers, flat, circular fasteners used with bolts, screws, studs, and nuts. Flat washers normally fit between a nut and the part to which it is being attached, or under the head of a screw or bolt. The washer distributes the clamping force over a wider area, and protects machined surfaces as you tighten the bolt head or nut. Flat washers are flat and continuous, they make a complete circle. Lock washers are also flat, but the surface is not continuous. This broken surface digs into the fastener and the component to prevent the fastener from vibrating or working loose. Shake-proof washers are star-shaped and have teeth that allow them to grip the component and the fastener when tightened. Dowel pins, fasteners that fit into pre-drilled holes to position two adjoining parts. Dowel pins require special pliers or a punch and hammer for removal. Dowel pins may be straight or tapered, solid or split. Retaining rings, also called snap rings. These are either internal or external and often hold transmission assemblies together. An external ring fits in a machined groove on the outside of a shaft, relying on spring tension from the ring to hold it in the groove. An internal ring fits in a machined groove inside a hole. You use retaining ring pliers to install or remove the retaining rings. Keys, small, rectangular, hardened pieces of metal that lock a gear or pulley onto a shaft. Half of the key fits into a key seat on the shaft, and the other half fits into a keyway on a pulley or gear. Clamps and vices. Whenever you work with any material, whether to cut, shape, drill, machine, or fasten, either with fasteners or glue, you need to ensure that the material with which you are working is held firmly in place. Clamps and vices are excellent at doing just that. Whereas vices are usually permanently attached to a workbench, clamps are removable and portable. Figure 8.16 shows an example of a clamp and a vice. Choosing the appropriate pliers. Pliers are gripping tools with opposing jaws that provide the gripping force when you squeeze the handles together. Pliers are useful in a wide range of gripping, pulling, twisting, and holding applications. Pliers are available in a number of sizes and are grouped by their overall length. Figure 8.17 illustrates a few of the hundreds of types of specialized pliers, and the following list gives you some more specific detail about each of the pliers. 1. Slip joint pliers, also called combination pliers. These are used for gripping small objects. They have curved jaws with small grooves or teeth that help secure the object being held. Slip joint pliers get their name from the hinged joint between their jaws, which can be moved or slipped to close tightly or open wide, depending on your need. You can use these pliers to pull out pins, bend wire, and remove cotter keys. Lineman's pliers look similar to slip joint pliers, but have only one opening setting and also include a cutting surface at the back of the jaw. Channel lock pliers, also called water pump pliers, are another type of slip joint plier that has several joint positions, and the jaws set at 45 degrees to the handles. Needle nose pliers, these have long, thin jaws that are useful for gripping very small objects, or for gripping something inside a confined space. Some needle nose pliers have curved or bent jaws for gripping around obstacles. They are often used for electrical applications, and might come with a built-in wire cutter near their hinge. Vice grip pliers, these pliers are necessary for any application that requires you to hold or grip with a great deal of constant pressure. In this way, they can be used similarly to a clamp. They can also be locked onto an object such as a rusted or frozen nut or bolt, and then turned with both hands like a wrench. Shop processes. Now that you have familiarized yourself with the most important shop tools, let's take a look at several shop processes that you need to know for the Asvab. Do you know the difference between welding and soldering? What does it mean to machine something? If you can answer these questions without batting an eye, you are in good shape. If, like many people, you aren't so sure how to answer those questions, read on. Exam alert. These next few paragraphs on shop processes contain information that will be good for at least 2 or 3 correct answers on some of the more difficult questions on the shop information test. If you are not already familiar with the shop processes described here, pay extra attention to this section of the review. Welding. Welding is a process in which 2 pieces of metal are permanently bonded, or fused, together by heating the 2 pieces where they join and filling the joint with molten metal. The result, when everything cools down and the metal recrystallizes, is a joint that is as strong as or stronger than the original metal. The heat can be supplied either by the flame from a gas torch, such as an oxyacetylene torch, or from an arc welding rig that creates heat by the formation of an intense high-voltage electrical arc between the welding tool and the metal object being welded. In either form of welding, the joining material is called a welding rod or filler rod, and can be purchased in varying diameters and alloys, depending on the welding task to be performed. Welding is a high-temperature process. The oxyacetylene torch produces a flame that can reach 6,000 degrees, and the arc welder cranks the heat up to more than 7,000 degrees. Welding is a process that requires training and plenty of safety precautions and safety equipment. Soldering. Soldering is another method of permanently bonding together metals, and is the same concept as welding, but on a smaller scale, and with different tools. Soldering is done by using a filler rod, solder, that is an alloy, or mixture of metals. Solder is typically made of a mixture of lead and tin. The soldering process begins with cleaning the metal pieces that are to be joined. This step is essential for a successfully soldered joint. Next, you apply a chemical material called flux, which prevents oxides from forming on the surface of the original metal. Flux also has properties that help break down the surface tension of the solder, allowing it to flow freely into the joint and bond with the original metal. Solder is applied using a soldering iron as the heat source. A number of different types of soldering irons exist, but no matter which one you use, you must first clean and prepare the tip by tinning it. Tinning is the process of heating the tip of the soldering iron, called the bit, coating it with flux, and then applying a thin layer of solder. The bit is then wiped with a clean cloth to remove excess solder before you begin your work. Because a soldering iron, and the part that is being soldered, can get very hot, you should exercise caution to avoid seriously burning yourself. Caution. Brazing. Brazing is a technique of joining dissimilar metals by fusing them with a filler rod made of an alloy, such as brass, a mixture of copper and zinc. Brazing, like soldering, produces a joint that is not as strong as a weld. Machining. Machining is a term for shaping materials with specially designed machine tools. Although the Asvab does not delve too deeply into technical information about specific machine tools, it is important that you know a little bit about a few of the most common machining processes, such as turning, milling, and grinding. Turning. Turning reduces the diameter of an object by rotating it around a horizontal axis, and then moving a cutting tool against the part. Turning is accomplished with a lathe, a machine tool that is useful for both woodworking and metalworking turning applications. Milling. Milling machines metal with a revolving, multi-tooth cutting tool into which the workpiece is fed. Milling machines are among the most versatile machine tools, and can be used to machine flat surfaces, drill or bore, and cut slots or even irregular shapes. Grinding. Grinding is a machining process for metal that is analogous to sanding for wood. Some common grinding applications are buffing, polishing, sanding, removing thickness, and leveling off a workpiece to achieve flatness. instead of cutting the metal. Grinding machines remove material by rapidly moving an abrasive material, such as ceramic, aluminum oxide, or composite wheel, block, or disc, or a wire brush against it. Grinders vary greatly in size, depending on the application, from huge machining centers, to smaller bench grinders, to handheld disc grinders. Because the whole purpose of grinding is to rapidly remove bits of material, you should always wear safety glasses, and use a safety shield between you and the material, if one is available, to protect your eyes from flying debris. Caution. Shop project planning. Before moving on to the practice questions, let's take a brief look at the shop project planning process. Complex projects need to be carefully planned, and the required steps and specifications should be documented. Blueprints are detailed technical drawings with all key dimensions indicated. They might even call out requirements for specific materials. Before beginning work on any project, you should study the blueprints carefully. The next steps you should take include preparing a complete listing of materials required, preparing templates or patterns for use in fabricating or checking parts, and laying out your project by marking out the blueprint dimensions on the materials you will need to cut or shape. Chapter 9.